I want to start sequences and series with some definitions. I want to make sure we're thinking of the same thing when I use certain terms. For instance, a sequence is just a list of numbers. They have a particular order, but otherwise that's all there is to it. A sequence can have a lot of terms, even an infinite number, but we usually write it compactly using a variable. For instance, this sequence can be written like this because when I plug in n equals 1, I get the first term, n equals 2 gives me the second term, and so forth. If we add the terms of a sequence together, we get a series. This can also go into infinity, and is usually written with the Greek letter sigma. Let me explain sigma notation real quick. Sigma notation has three parts: the starting point at the bottom, the ending point at the top, and the sequence to the right. It's formatted pretty similarly to an integral, but there are some pretty big differences. To evaluate a series, first you plug in the starting value at the bottom into the sequence. This becomes the first term being added on the right. Then, you increase the value you just plugged in by 1, and plug it in again. So in this case, that means I plug in 3 now. I add that value to the previous, and then I plug in the next value. I keep doing this until I end up plugging in the final value, the one on top. If the value on top is infinity, then there is no stopping point. You just keep adding forever. As you might be able to guess from what you learned about improper integrals, infinite series can also converge to a single number. Now, most infinite series are going to diverge, of course, but there are some series that you bring all the way into infinity, you add an infinite number of terms, and it still ends up adding to a single finite value. Now, adding infinite numbers in your calculator sounds like it might just take a while, so let's talk about some alternatives. You might have heard of the term partial sum. This is just the partway point of an infinite series. To find a partial sum, just pretend the stopping point of your infinite series is instead a finite number. So, for instance, a partial sum of this series might look like this. Partial sums are usually written with a capital S and a subscript of the number. Now, I bring this up because partial sums are essential to our evaluation of infinite series. Specifically, an infinite series is equal to the infinite limit of its partial sums. Basically, if the partial sums seem to be approaching some value, the infinite series is equal to that value. Now, most of the time, we're not going to be dealing with this limit directly, but they can still be useful definitions. In fact, most of the time, you won't be finding what an infinite series converges to at all. Instead, you'll just be finding whether it converges. Basically, a question might just ask if a series converges. It's a yes or no question. You wouldn't need to find its value. This is because even answering that yes or no question can still be kind of a hassle. Instead of using the limit of partial sums, we'll refer to a table of convergence tests. These tests can often tell you something about whether a series converges or not. However, they are very limited, which is why we need so many of them. To show you what I mean, look at the divergence test. It says that if the terms of a series don't go to 0, then the whole series diverges. However, it can only tell you that. Notably, this test cannot tell you that the series converges under any circumstance. Each test has conditions for which it is inconclusive, meaning the test tells you nothing. It just fails. There are lots of tests we could look at today, but each of them could be their own subject for a video. So instead, I'll just recommend looking at them independently with this context. For each one, try to make sure you know what the test can tell you, sure, but also make sure you know when the test is inconclusive. If you keep all of this in mind, I think you'll be in a pretty good place to learn everything else you'll need to know about sequences and series. Hope this helped. Bye!